Hello, and welcome to Exploring Axon, a podcast where we discuss Axon Framework, Axon Server, and their ecosystem. I am your host and a software developer at Axonic, Sarah Torrey. In this episode, I spoke with one of my colleagues and a software architect, Fred Gendobien, about the possible patterns when designing a distributed system in CQRS. We first started by talking about uniqueness constraint, what it is and why is it important, and how we need to be careful when designing these constraints. We then discussed several patterns in which you can better design your distributed systems, especially when discussing these items in command query responsibility separated patterns. Fred described 5 different patterns which he talked about each one of them in detail during our talk and why each one of these patterns is important and how they can then communicate with each other through a possible message router or a server or other ways of connecting them and communicating them. I hope you enjoy this episode and let's have a listen. Hi, Fred. How are you today?
Hi, Sarah. I'm feeling sick, but it's okay.
Caught you at the right time, didn't I?
Yeah.
Well, thanks for being here, anyways, despite you're not feeling really great today. But I'm glad to have you. So, can you, before we start talking about the topic of the day, which is something that I was really excited to learn about a couple of weeks ago when you and I spoke, and I'm excited for everybody else to also learn more about it. But before that, tell me a little bit about yourself, where you are, what you do, a little bit about your background, whatever you'd like to share.
Yeah. All right. So I'm living in Belgium. Finished university like 12 years ago. Yeah, university in computer science, obviously. It was the theoretical part, so really theoretical computer science. I
Hmm.
know that sometimes you have uh, what we call pure computer science and what we call something to manage a company, right? I did
Okay.
really the pure technical and theoretical part.
Nice.
So finish up with the artificial intelligence, and I really thought back in the days that I would make it my career, but as you
Hmm.
see, it's not the case.
Life
Life
sometimes has
happened.
different plans, right?
Yes, yes, exactly. So I started my career in the banks, actually,
Hmm.
the big central processor for the bank in Belgium.
Hmm.
And this is where actually I started to play and work with CQRS and event sourcing, even
Okay.
though it wasn't called event sourcing and CQRS because those terms didn't exist back then.
Right.
But I started with this. So
Yeah. Very cool.
then I did a lot of other companies, and then I started to really play with those patterns. Like 8 years ago,
Hmm.
I was the tech lead, became the application architect, and yeah, this is where when I really decided to focus on that. On that.
Nice. We were at a university a few weeks ago, and Allard, our CTO, was talking to a group of students about some of these patterns, CQRS and domain-driven design and things like that. Um, and some of the students had some presentations ready too. And so when they were giving these presentations, and you see their eyes are just bright and so excited about whatever topic they were talking about, and then afterwards they come and ask questions and things like that. So when you mentioned, I thought I would go to the direction of artificial intelligence, but then that didn't happen. Kind of reminded me of we were kind of joking at, oh, they're so excited and enthusiastic, and they're like sponges. They grasp everything you tell them. So what happens after that? Your first job happens, and then you're put in a different direction. And sometimes that
Yeah.
direction turns out to be something you actually enjoy, and sometimes it doesn't. So I'm glad that this was something that you actually did enjoy, and you seem to be enjoying it still, which is great. So
Yeah, indeed. I enjoy it.
Nice. Now, we talked about a topic that I had come across, of course, and had heard a lot about it, but not really dived any deeper into this specific one, which is the topic of uniqueness constraint. So, when you shared some of the slides that you had, and you had done some talks about this particular topic and other topics within that conversation, we thought, hey, let's just record this. This is great. So tell me and everybody about uniqueness constraint. What is it and why is it important? And do please state the obvious.
Yeah, yeah, of course. So, what is a uniqueness constraint? So, everything is in the name. It's certainly
Hence the
something,
obvious part, yes.
yeah. So, you want something to be unique. Like everybody knows, the use case of having a unique email address for users, that is a uniqueness constraint, right? But this one is very simple. Sometimes it could be much more complex than this. Like,
Mhm.
for instance, for the bank, email address is not relevant.
Right.
It's probably your national register number in Belgium. I don't know if you have the same in USA. I guess you have something
Something similar,
similar.
yes. Yeah.
Yeah, but
Social
sometimes
security number, usually, yes.
yes,
Mhm.
yeah, that's the one I was looking for, but I just
Right.
forgot. Um, Sometimes you cannot use this number for a GDPR reason.
Right.
Back in the days, GDPR didn't exist, but we couldn't use that number everywhere because you needed to have a kind of certification, security certification, which is really, really high in Belgium.
Yeah.
So sometimes people just took a very bad decision, but a kind of holistic decision on the uniqueness of a customer is based on his first name, last name, and birth date and
Hmm.
place of birth, for instance,
Okay. Okay.
which of course brings clashes and
Yeah.
conflicts. But it was something, right? If you cannot
Right.
use the national security number or something similar, yeah, you had to use something.
Mhm.
So uniqueness constraint is something like that. Make sure that your users or your data is unique into a system.
Right.
That's a definition.
Yeah. So now it's obviously it is obvious what it means, but in a bit of a context it makes more sense, and of course it's important, but I can imagine that with that case of having a series of information kind of concocted together, your name, last name, birth date, place of birth, at any point any of these parts of this one information changes, let's say you move, or or actually moving, I guess, doesn't make any difference here because your place of birth is the same. But in the case if you, for instance, get married and your last name is different, then that can cause some issues. And with something like event sourcing, when your events are immutable and shouldn't change and your information basically shouldn't change and things like that, so I can imagine that brings in some um, complex situations, maybe. But before we get to that, you did mention during the conversation that you and I had that we should have a little bit less constraint. And why is that? I can have some guesses, but I like to hear your point of view on this.
So for me, those constraints are really important, and you cannot avoid them, and that's
Right.
really important to understand because yeah, for if you go to a bank and you say, yeah, unfortunately, I've built a system, a very nice system, but you could have duplicate customers if they
Mhm.
click twice on the button. The bank will say, yeah, that's not an option. Sorry, do it
Right.
again, of course. So, but the thing is, we shouldn't base everything on that. And
Right.
so, when designing constraints, we should design them really carefully. That's what I meant. So,
Hmm.
avoiding them, it's sometimes not an option.
Right.
And but we should try to be really mindful about them. So, we
Hmm.
don't do anything stupid with constraints, like
Right.
put a field that is supposed to be changed every 5 minutes. It won't
Right.
work, right?
Yeah.
So that the design of it is really important.
Exactly.
And especially in CQRS, actually. CQRS system makes the uniqueness constraint very complex, but
Mm-hmm.
at first glance, right?
Right.
Because you see, there is a write model, there is read models, and when you want to add something, you say, okay, my aggregate is responsible for its own life, but when it creates itself with a uniqueness constraint, it's actually something that spans over multiple aggregates.
Exactly.
And that what makes it more complex than just do something on my aggregate. No, it's actually create my aggregate with a condition that span over multiple aggregates. And back in the days, we had no other option to use a database for this.
Mm-hmm.
And I was really, I'm not a big fan of database. So that you know, that's a
That
thing.
I know.
So
Yes.
yeah, it's not that I'm not a big fan, but if I can use something else than databases, especially for write model,
Mm-hmm.
I will. So when I was learning the actor model back in the days, really long time ago,
Yeah.
they came with a very clever and simple ideas of your constraint is actually an actor on its own.
Mm-hmm.
And that's the where it's actually completely different from what we saw on the internet. Just put
Yeah.
a constraint into a database and work will be done. No, no. There, it's an actor model. Of course, an actor model is composed of actors. Actors are a bit like aggregates.
Mm-hmm.
If we look at the axon stack, right? They really look like. And there, they were saying, okay, whatever your constraint is, one field, multiple fields, whatever, just create a unique key, a unique
Mm-hmm.
identifier out of it.
Right.
You can do it using hashes, using concatenation, whatever.
Yeah.
Whatever takes multiple values and create another value. That works. And
So
this
in
is
this
the
case, is it
idea.
kind of,
Yeah.
yeah, sorry to interrupt you, but in this case, is it sort of translating for me into Axon language? Would that be then the aggregate identifier, for instance?
Yes, exactly.
Okay,
Exactly, yes.
perfect. All right, great. Carry on. Sorry.
So you create actually the aggregate identifier.
Hmm.
So one value out
Right.
of multiple values. And you ask that aggregate or actor, can I use you? Are
Hmm.
you available? And of course, because actors and aggregates in the Axon stack are concurrency free,
Right.
they ensure the concurrency for you. That's very nice. If you say, now I'm using you, next time I want to use you, no,
Hmm.
I'm already used. So you can actually reject duplicates. Really using the aggregate actually. So no need for database, no need for external system, just
Hmm.
an even store and some aggregates in the system. It works
And done. Nice.
and done. It's not, and this works not only for uniqueness constraint. It also works for sequence generation. A lot of people say, yeah, if you want, for instance, to generate invoices in a system, you need to have a sequence number without, I would say, without holes. So the sequence should be natural all the way. And they were using a database for that. But I told them, hey, same problem.
You don't need that. Exactly.
Yeah, you don't need a database. Use an aggregate for this, and just on the aggregate, you say, give me the next number,
Hmm. And
and
voila.
give and set, of course, and voila.
Of course. Yeah.
And some of our clients were actually using a Postgres cluster on
Hmm.
in the cloud just
Yeah.
to do that uniqueness constraint and sequence generation. Then I told them, now you can ditch it. You have the Axon server, and you have so it works. And they were saying,
Yeah.
no, it's not true. But if you don't believe me, we can try. So we
Right.
tried. It took us 1 hour to modify the system and use only actors.
Hmm.
And they were like, so installing in test, and it took one
Sure.
hour. So it's,
Right.
yeah, it was quite fast. And they were
Very
like,
fast. Yeah.
damn, it's working. Yes, it's working.
Like, I told you so. Yeah.
Yeah, and now we can remove the clusters, which we pay. It was something like, yeah, really, really a huge amount of money just
Astronomical.
for
Yeah.
a cluster. Yeah.
Yeah. Yeah. I can imagine.
Just for that, it's huge. I mean,
Yeah.
just to use it as a sequence generator and
Mhm.
or uniqueness constraint checker, it's really too much.
And
So
it's
yeah,
uh,
it was
it's
a good thing.
it's great that you mentioned that because as you mentioned about the design of things, that's where it boils down to. A lot of times, you kind of go back to it and say, hey, what can we change in the design of the system? And changing just a few things can actually save you a lot of money in the end, which is what we all
Yeah,
like, right? Um, so one of the things that you mentioned also was um, the whole notion of chaos oriented approach to a lot of this design, right? Tell me a little
yeah.
bit about that. The name of it kind of makes me nervous because it's chaos and I don't like chaos, but maybe it's a good thing. I don't know. You tell me.
Actually, the whole world is about chaos,
Of course.
so you shouldn't be afraid.
And my
But
whole world is about to making sense of that chaos and then go back to
yeah,
another chaos, which is great.
exactly. The
It's all the
universe and
fun.
the sun and the stars and everything is chaos. So
Exactly.
by chaos, chaos engineering and chaos system, I was thinking about, yeah, the very naive approach when you create a microservice oriented architecture is to put a lot of service together and they call each other. There is no boundaries or constraints.
Of course,
Um,
nothing can go
and
wrong there, right?
yeah, of course. And you have like, if you have 5 services, it could work. When you have 50 services, you just have a big ball of mud
Hmm.
with a full mesh interconnection. And when something goes wrong, you dig it into it for months and say, "Oh, I think I understood. Now we can provide a fix." But the system has changed, and actually your fix is
You were
not
in the
relevant
month that you were
anymore.
looking. Yes,
Yeah,
exactly.
and now you cannot reproduce the problem. So you're like, "Oh la la,
You
what the
can
hell is
reproduce
this?"
that problem, but then another 50 problems have occurred during that
Yeah,
time.
of course.
Probably. Yeah.
So that's a problem of the naive approach of microservices. So you have a kind of full mesh interconnection between all
Hmm.
services. I don't like this, and
Yeah.
especially in CQRS, well, I'm sure it goes beyond CQRS architecture, but especially in CQRS,
Hmm.
you can do better than this. You can have a tree-like approach, and I say
Hmm.
tree-like. It's not. It's because it's not really a tree. You have cycles, so of course
Right.
mathematicians will say, "Oh, he's speaking about trees, but there are cycles, not a tree." Yes, it's not a perfect tree, but it looks like a tree.
Right.
That's what I.
Tree-ish
Yeah,
method,
it's
right?
tree-ish. It's like a very weird tree where you have branches going back into the trunk.
To
Okay, it does
loop
not
it.
exist in the
Yes.
nature. Yeah, but okay, there in me, I said something like a tree.
Mhm.
And to do that, so that was my mission actually years ago when we had a lot of services playing all together, a lot of external services, clients, systems playing together. And it was very difficult when we had a problem to monitor everything and to understand what was the problem. And then we started to say, okay, let's define some rules actually of a service. What can a service do? Sorry,
Yeah.
and we were saying, okay, service can obviously receive a command, and we were already in CQRS, so I'm getting through the whole process of putting CQRS, defining what it is, blah blah blah.
Sure.
No, so a service can obviously handle a command, accepting the command, and by producing an event. So
Mhm.
handling a command, producing an event, fetching events because it needs to, in event sourcing approach, you need to rehydrate your state. So,
Right.
okay, getting events as well, producing events. Of course, I can produce commands because at some point you need to produce commands. The same for queries, handling and producing queries. And we were like, okay, if we don't put some rules or if we don't define some patterns,
Yep.
A service can do anything, and you will end up with a big ball of mud,
We're
full
back into
mesh.
chaos.
Yeah,
Yes.
back into chaos. And this is something we really wanted to avoid, of course.
Hmm.
Um, and I define back in the days, I really like the divide and conquer approach. So I
Yep.
said, okay, we will take the theory of CQRS, so write model, read models,
Hmm.
and then put as many constraints as possible, which is sometimes we want to break the constraints. No, I
Yeah.
said now we put a lot of constraints.
Hmm.
I want my right model, the one who is taking decision, to be completely isolated.
Okay.
And the other architects were looking at me and say, wow, you're completely crazy, service completely isolated, it won't work. I say, yes, I want him to be able to work
Hmm.
completely alone.
Right.
He doesn't have to know there is another service or who is calling me. I don't care.
Hmm.
Who will read my events? I don't care. I will just play with my commands
Right.
and produce my event.
So
That's
in
it.
a way, you're playing with the idea of location transparency.
Yeah, yeah, exactly,
Nice.
exactly. That's really the thing. So
Yeah.
back in the days, we had a RabbitMQ. It was like 8 years ago, huh? So
Hmm.
RabbitMQ was still a thing. Sorry for the guy who are still using RabbitMQ. I'm not saying it's not a thing, but it was
I
it
think it's
was good
very
back
much a
then.
thing still for a lot of people. But yeah, I'm really
Yeah,
curious to see what you did with it. Yeah.
and so the idea was really a service had its own queue
Hmm.
and we're and its own topic,
Right.
and that's it. Commands
Hmm.
were putting into the queue and events putting into the topic. And that
Hmm.
was actually the thing. And we said no connection to other services. That's the
Okay.
thing. All right. Then we said we need to view the data
Right.
because CQRS without
You
the
got to do
queue,
something with the data. Exactly.
yeah, you do
Right.
some business, but you cannot really look the data. So
Right.
we said, but can't we do the same thing with the query models?
Mhm.
Like the only thing they can do is read events and respond to query.
Right.
The
And
only
nothing
thing,
else. Right.
and nothing else. No, no query aggregation or calling another. No, just this.
Yep.
Sometimes, of course, yeah, you have to play with very old services which are not CQRS ready,
Right.
which with a very I shouldn't say stupid, but stupid SOAP interfaces, something like that.
Right.
Maybe something you don't want to play with.
Hmm.
And of course, you want to make them CQRS compliant. So
Yeah.
yeah, okay, you will do this by they will accept queries and you will actually fetch the system back, interact with the whole system behind the scene, of
Yeah.
course. Um, but let's say that in the ideal world we don't have external systems. We just read events and respond to query.
Right.
That was the second patterns.
Hmm.
And then almost immediately we were like, okay, but something is missing. The business came and we're saying, okay, it's cool. Now you have an inventory, you have activation of the broadcast. You have I was in the broadcasting world,
Okay.
so you have to install the device, you have to manage the stock, you have to manage the broadcast signal, blah blah blah.
Hmm.
But because everything is isolated, how do we do this? They
Right.
say, okay, there is something missing. So the first idea of a human being is, let's break the rule. They will play together. And I was like, no, I won't break that rule. They will be isolated. And they
Hmm.
were saying, yeah, but you're crazy. You don't see the problem. I say, yes, yes, I see the problem. Something is
We just
missing.
need a connector.
Yeah, something is obviously missing, and we shouldn't break the rules. So immediately we saw a few things, like what we call the saga, right?
Hmm.
The saga pattern came almost immediately after the first problem of
Hmm.
design. Say, we need something that if we want to do something, actually breaks that something, that command actually, into several commands and
Hmm.
make sure that those commands are executed
Right.
synchronously.
Hmm.
So it was the definition of the saga.
Yep.
Say, okay, then we will have the pattern saga, and the only thing it can do is process a command and produce commands, different
Yep.
commands. And so that was the third pattern.
Right.
Then we were like, okay, sometimes we want to do processes, asynchronous processes, because
Mm-hmm.
imagine a bank. I always take that example, really like that example. In a bank, you imagine we have customers, bank account, cards,
Mm-hmm.
and for a reason we want to split them into right models, really isolated right models. We could have customers without bank accounts. Why not? Resellers, I don't
Sure.
know. Why not? But we can have bank accounts without cards because
Okay.
cards is a very old thing.
Yeah.
We are still using cards. I hope that
Would like to
within
get rid of
five
it.
years, yeah,
Yes.
of course. I don't use cards anymore. I have some, but I don't use them anymore. I use my phone, of course.
I
Beep
had
beep.
to use my
And
card the other day, and I felt so snobbish because I was irritated at the machine for not taking my phone. It needed a
yeah,
card, and I was chuckling at myself. I was like, "Yeah, the 21st century problems here, of course."
yeah, I had the same problem in a bar. The guy was
Right.
like, cash or card? I say neither.
Cash.
I say, neither. What do you mean?
I
Yeah,
know.
it's not for free. I say, no, no. I will use my watch. Your what?
Yes,
No, my
exactly.
watch.
I was having lunch on Saturday with an old friend of mine, and she wanted to treat me to a fine. And she said, "Well, if you really feel bad, you can put some cash for the tip." And I said, "Cash? Who carries cash anymore?" She was
Yeah,
laughing.
you mean that
You
I
are
have to go
way
to the
old
ATM?
school.
Yeah,
I was like, "Thank God you didn't ask me for a check, so I can write 79 cents on a check and be done with it."
yeah. I don't use cash and I don't use cards anymore. So it's sometimes very difficult for me. But yeah. So, but you understand.
Anyways,
So
going
that's
back to
why
it, of course.
I
Right.
don't want to put the card into the bank account right
Mhm.
model, or should I say, context, because one day I will, and I hope, remove this from my system. So
Yep.
I just want to remove completely the bound context, all the containers related to that bounded context, and say,
Mhm.
okay, now I don't have cards anymore, but my system is still running, and
Right.
I didn't have to modify any other pieces. So
You
that's
actually
cool.
don't have to modify the code, which is great.
Yeah, you just remove containers.
Right.
That's cool.
Easy.
You register a new customer, and the guy say, the business guy says, yeah, now if you register a customer, make sure he has an account.
Mhm.
Okay. And the other guy said, yeah, but if we create an account for now, create a card. So,
Mhm.
okay, so it's a you see the cascade.
Yeah,
Say, all right, the chain reaction, and of course you don't want to do this
because then everything's
synchronously.
connected. Yeah.
Yeah, so you
Right.
just say,
Synchronously. Yeah.
okay, register yourself. I am Frédéric Jean de Bien, blah blah. Okay, you're now a new customer. Welcome. And behind the scene, an account will be created. And when the
Mhm.
account will be created, behind the scene again, the card will be created. You don't
Right.
want everything to be synchronous because if the card is not created for a reason, you
Mhm.
don't want to kick out the new customer, of course. It would be
Exactly.
a very
Right.
bad strategy. So what you do is you keep retrying, retrying
Right.
to create the card, but you just say to the customer, "Yeah, welcome. Everything is
Everything's
fine.
fine. Right.
You will receive your card eventually, hopefully,
In the mail.
but everything, yeah, and everything is fine."
Mhm.
So we were like, okay, the saga is not an option, so we have to do something else, and the name was processes, right? The new
Right.
pattern. So now we have how much right model, query model, saga processes,
Mhm.
four patterns.
Right.
And I was like, I'm not happy with this.
Something's
Something is
still missing.
missing.
Yep.
Something is still missing. And the other architects will say, no, no, what is missing? I say, the protocols.
Exactly.
And they were like, what do you mean? You know that we have a lot of different customers, we have a lot of different systems that are actually calling us. And for some of them, we need to expose a SOAP interface. I'm really sad. Some of them is JSON RPC.
Mhm.
Still sad, but it's way
A
better.
little bit better.
Sometimes, yeah, sometimes gRPC thrift. That's.
That's much
I'm
better.
starting to feel. Yeah, I'm starting to feel really
Less
excited.
depressed. Yes.
But yeah, less depressed. But the problem is you cannot impose those protocols to all the clients because
Sure.
some of them are really old-fashioned.
Hmm.
And you can imagine, with in the banks, my first protocol was. I'm not sure I can say. Yes, I can say this. I was counting the years. The I received a mail. All right, I received a mail file, CSV through mail, and I have to process it. I was like, oh right, that's a protocol, cool. Uh, of course, depending on the customers and the systems, we have to provide as many protocols as possible.
Hmm.
But I don't want to modify my code base, and I don't
Right.
want to modify especially my core.
Hmm.
The core was asynchronous by design, but for some customers, we had to provide synchronous API protocols.
Right.
And I was saying, what about creating this pattern,
Okay.
protocol actually,
Right.
so that we can multiple multiply them, sorry, and we will propose as many protocols as possible, depending on our customers or different systems.
Right.
And the idea was quite cool because we could have SOAP, JSON RPC, gRPC Thrift at the same time, based on the
Yeah.
same core platform. So I said, here it is. I have my fifth pattern.
Nice.
And now there is another problem: is okay, can we mix them now? That was the
But
question.
then you go back to the chaos if you mix all of them together.
Yeah, and then I said, okay, let's try to optimize a bit the number of deployable that we create.
Hmm.
So by mixing patterns, but make sure that we have rules.
Right.
For instance, does it make sense to mix a write model with a read model? I know a lot of people are doing this, and I'm sorry for them, but no, it doesn't make sense for me
Yeah.
because in the scaling theory, write model will be sharded, read
Hmm.
model will be replicated.
Right.
So if you want to mix all of them together, and you want to say, for instance, I want to have 3 instances for the write, 50 for the read. How do you do that? Because my system is really much used for read, but not so
Yep.
much for
For the
write.
right.
You can't do this. So it's bad.
Yeah.
Don't do this. So, of course, we don't mix write model with query models, but maybe we can mix other patterns.
Okay.
And we actually started to look at all the patterns, and I was like, okay, protocol and queries are really for the last thing I design. This
Hmm.
is not the business, actually.
Right.
People were quite shocked at the beginning. Say, this is not the business. What do you mean? And they said, what do you mean it's not the business? Of course, it's our business to provide an API and protocol. Say, no, the business is to make sure that all the right models are coherent, right?
Hmm.
The stock is coherent based on the location of the devices that we sold, but the protocol, we don't
It's
care.
not. Yeah.
Yeah, we don't care. Even the views to show the data to people, to support people or whatever, I don't care.
Yeah.
This can
That's
be
still not part
changed
of it.
actually.
Exactly.
Yeah. So we were saying, okay, protocol and queries are actually part of the user experience, not the
Hmm.
business.
Hmm.
And the rest, so right model, Saga processes, are
They
really
are
the
part of the
business.
business. Yeah.
So you can mix patterns to optimize
Hmm.
if you are in the same part, which is business parts or UX
Right.
parts.
Hmm.
It makes sense.
Yeah.
Otherwise, it doesn't make sense. So that's why no write with a query, please. Even though
Exactly.
we have location transparency, yes,
Yes,
in
but you still don't want
theory,
to mix.
yeah,
Right.
in the practical world, you don't want to do that.
But I think we missed one thing, right? I think we missed I guess, the one thing in between them, which could be your message router or something that communicates in between uh,
Of course, of course,
the patterns. Yes, which is kind of obvious, but I like to state the obvious. They have to somehow communicate, right?
of course, of course. So to make them communicate, of course, you need something. Message router, which is compliant with the CQRS.
Mm-hmm, mm-hmm.
So you should be able to route a command, route a query, route an event, which
Right,
actually those messages have very different schema for being routed.
right.
And of course, you need to have the store because we were an even source system. So of course, an even store.
Put the event somewhere.
Uh,
Exactly.
and that's where I want to come back to the Axon stack because if you think about the Axon stack, it's actually the server. The
Yeah.
server is all of that
Right.
in one
Right.
piece of software. So that's great. Back in the days, I had to use RabbitMQ and a Postgres, for instance.
Yeah.
It was working, of course, but the distribution and all of these things were actually complex
Yeah.
because it's complex to set up. The
Exactly.
RabbitMQ cluster, the Postgres cluster, they're not so easy to set up. So
Mhm.
yeah,
So the setup itself is one issue, and then I can imagine they maintenance it and the everything else that comes with the changes within the system add more
yeah,
complexity
yeah,
to it as well.
yeah, indeed. And so those technical parts were really handled by big teams actually for us.
Mhm. Yep.
One
But now
was
having the Axon
tackling the
server, exactly.
yeah. Now with the Accent server is one component you have to maintain, not two. That's
Right.
even if it's one, two, doesn't look like yeah, it's not that much.
Doesn't look like a lot. But when you get to the nitty gritty of it, yeah, it can
Yeah,
cause a lot of issues.
exactly, exactly.
Very good. So just to recap the patterns that you mentioned, because I think that's really important to kind of go back and really look at the five patterns plus that message router in between. So we do, of course, with the CQRS, you have the write model, your command side,
Yeah,
business side. You have the read model, your views, and then in between to um, sometimes you need a saga or translator, sometimes you need process, so you have those other two patterns, and then of course the protocol, which came so sort of towards the end of your discovery mode about how do we want to then deploy these various systems and want to define, and then the way to communicate between them, the way to store these events, then a message router, or in our case Axon server, can come to the rescue, which is really great. Fabulous. Very good. This is really interesting to see your process because it's such a personal, I think, discovery mode that you went through with various projects that you had in mind. And also throughout the years, as things became a little bit more concrete and more defined, it made your life easier because then you have patterns to go by. And it's really nice to see the process a lot of times because various people have various processes, and it's really great to see what's worked for you and what you um, have come to at the end. This is, hey, this is works, this is great. Now
yeah, indeed.
I know you work with a lot of clients. Does Is it an kind of a loaded question, but is it an easy process? What has your personal experience been within different teams? Is it sometimes really hard to get people onboarded with what you have to offer, or have you noticed that when you show them the result, kind of like the example that you gave, in 1 hour, they could see that difference? Then it's kind of like that aha moment that they're like, okay, yes, this is the route we want to go to.
Yeah, that is a tough question actually.
I guess
So actually,
my favorite answer would be depends.
yeah, but actually, yes, it depends. It's but I don't like the it depends answer. So I will go a bit into
Thank you.
detail. For me, the technical parts is always easy.
Hmm.
At least for me, technical parts is always easy. I
Well, I can
failed
imagine because
one
you have a
time.
proof, right?
Yes, yes, you have a proof.
Yeah.
But the problem, and especially here in Belgium, I don't know, maybe the other countries, is we have a lot of ego for a reason. And
Many of
if
us do.
someone comes with, yeah, if someone comes with an ID, it's very difficult to accept the ID, and
Yeah,
that's a
yeah.
problem, right? And this is where I failed big time.
Mhm.
It's not putting theory or bad architecture. No, because
Yeah.
for me, architecture, if you follow those patterns, is really easy.
Mhm.
But it's to manage the people who are not convinced.
It's the mindset that takes
The
longer.
mindset,
Yeah.
exactly. Because so what I learned through experiences is you need to let the client think they came with the ID, and then it will work. Actually, you explain everything, all the constraints, and they will you actually really guiding them through the process of saying exactly what you want them to say, and then it works.
You make him sound like it was their idea, not yours.
Exactly, exactly.
Right.
So it looks a bit like manipulation, but it's a good manipulation.
Exactly.
It's
But is I feel like that's the way a lot of times I parent, make them think that they came from them as opposed to you
exactly,
telling them exactly what to do. But yeah,
yeah.
that's really interesting, and I think that's a common challenge for a lot of people too, especially architects, especially those who want to sort of adopt new patterns for clients and such. And at our conference a few months ago, we had sort of a Q&A session, and somebody said, so they asked the question of how do you deal with folks who are working with legacy systems, really old systems, let's say a 30-year-old system, and you want to now bring these patterns into play, and you have the architect who's been working on this system for the past like 25 years, and how do you get them on board? And um, I made a comment that, hey, during the at that point we had about 50 episodes. Yours is going to, I think, be the 60th episode. So hooray! This is celebration. And I said a good 2/3 of those episodes are people complaining about the same challenge because it's not an easy one. It's tough, but props to you for fighting the good fight and for keeping it going.
But most of the time, I ask this question because they ask me, why should I use your patterns? I say, if you are happy with the current solution, you shouldn't. Are you
Yeah.
happy with the current solution? No.
So there
Everything is frozen. Nothing is working correctly. We have bug fix waiting for 2 years,
yeah.
and we have concurrency issue. We have blah blah blah. We have a lot of issues.
Mhm.
I said, that's the answer.
There you go. That's the short
Yeah,
answer, of course. And of
yeah.
course, if everything's
Why?
working, then they probably wouldn't call you, right? If everything's
No.
working, then everything's fine. If they're happy with it, then go for it. Keep on going.
And it's actually a very funny thing that I ask all the time because so technical leaders they don't like you. See, you come, you're an architect, you say technical leaders, I designed a system and I think it's working, and then the management say no, it's not. It's really like not good, let's say,
Yeah.
and uh,
Put nicely.
and you come, yeah, put nicely, say not good, and you ask a question and say, yeah, I'm not sure. I agree with your solution. Say, of course. Is your solution working like you want? Can you do this and that and that? Uh, no. So you're not happy, but you don't want to change.
Yeah.
What do we do then? It's like, what do we do? You
The
continue
choice
like
is
this?
yours.
Wow. Yeah, you continue like this. For me, it's fine. I just go somewhere else. I have,
Yeah.
to be honest, I couldn't care less.
Yeah.
But if you want a system that works, we need to improve. I'm not saying that I arrive with silver bullets, but I
Right.
arrive with a foundation which is working.
Exactly.
And then we can improve and put and define new
Yeah.
stuff. That is
And I
cool.
think that's important that you mentioned that because you don't arrive at the back of a unicorn and say, "Hey, it's going to be rainbows from this point on." But it's important, I think, a lot of times some folks don't realize how much work it takes, and it's a timely process. It doesn't happen overnight. It just needs a lot of patience and it needs time. But once you get to the point that you want to get, and the system is um, functioning how you like it to function, then you've arrived to that almost rainbow. Of course, you have to constantly maintain it and adjust it as you go, but at least you have built the foundations, the solid foundation that you want to help you kind of go on for hopefully several years or decades the way that you want to
Yeah,
proceed. And of
indeed.
course, as with anything, patterns change, architectural preferences change, and things like that. So it's an ongoing battle. It never ends, right? It never stops.
Yeah, yeah,
There's
of
always
course, of
something more
course.
you can do with it. But starting from a good point always is helpful. But I really want to appreciate you being here today, despite you not feeling so good. So thanks for being
Thank
here
you.
and sharing your really great experience with everybody, and breaking it down into a very cohesive way to look at it and understand. You have had a talk about this in the past. If it's publicly available, I'm happy to share it as well on the notes of the podcast, or any other information that you want to share. I'll get on that as well.
This
So
is on the
that'd be
yeah,
great.
this is on the Axonic YouTube channel.
Okay, fantastic. So I'll share that with everybody so that they can actually
Yeah,
look at the slides as well. I think it's really helpful if they have the visual also. Again, thanks a lot, and I hope you have a great
thank
day.
you,
Feel
Sam.
better. Talk to you later.
Thank you very much. Bye
Thanks.
bye.
Cheers. Thank you for listening to this episode. I hope you enjoyed it. Please join me next time for other amazing talks with wonderful guests. Until then, have a great time and happy coding.